Now we start with the actually FakeRainFinal.shader. In this part I want to create a lambert which can distinguish between two textures and blend those how we want to. Mainly a linear interpolation will do it, but we tweak a bit around with some variables. And this method also using big titles to create snow, dirt or other stuff. In our case we want to distinguish between raindrops on the top of our object and down floating raindrops on the side of our object. Again, we need a few new variables to define. The underscore rain texture is the custom texture which contains three different textures. In the first channel you find the raindrops texture, in the second channel you find this rain side texture, and in the third channel is a palette noise texture to blend between the first two textures. This special custom texture you can find also in the download package. The underscore up direction defines the literary up direction. There might be a built-in variable for this, but now you can change the direction by yourself. The underscore transition defines the width of the gradient between the top and the sides. The height where the transition starts defined by the underscore raindrop amount. Finally, the underscore raindrops power shows how strong the top texture is visible. Now we must extend our pragma lines with hash pragma target 3.0. This is necessary to compile the shader model 3.0 and using direct 3D9. By the way, we can now also use way more instructions. Don't forget the declaration of the variables. Because we want to work with the UI coordinates of the underscore rain texture, we extend this input struct, and we want to use the world normal. We need to define the exception flow3 world normal and the internal underscore data without a semicolon. Now we get to the range surface function. First of all, to use the world normal, we need to place the normal output on the first place in the function and add the line half3 world normal equals a world normal vector in point normal. With this line we now get the normal vector based on per pixel normal texture, not anymore on per surface normal. Now we want to calculate a value that decides which texture needs to render and which does not. We define the noise texture, the last channel of the underscore rain texture as a based information to take a random look on the transitions shape. Again, we use the helper function half dot with the world normal and the underscore up direction to get a value which finds out where smoothly the up direction of the object is. I use half.1 for this value because the compiler has problems to distinguish between a function and a value. Next we calculate the shift level between the top and the sides by multiply the half.1 with the underscore raindrop amount. To control the power of the amount, we use again the pow function in combination with the underscore raindrops power. Here we calculate the long-awaited transition value through negate the negative shift level, and at the noise we get our cap for the top. With the max function we get sure that nothing below nothing goes below 0, and with divide by underscore transition we define how much the cap covers the side texture. And with the saturate function we get again sure that we are in the sweet spot from 0 to 1. With the transition value we can now do the linear interpolation or short lerp between two textures. For this I make an example where I put the result into the specular so you can see the layer mask. We read the information of the first texture top and the second texture side, and we put both values in the lerp function. Mathematically we calculate the second value minus the first value, this multiplied by the third value, and finally add the first value. Now we add the specular lerp to the specular color by multiplying it. Because we changed the order of the output, we need to rewriting the normal output. This we need again in the next step. Just copy and paste it and rename the normal and rename it to normal value 2. Then very silly, I just forget the target and the pragma line and the second pragma line. And don't forget to attach the checker texture in the third texture slot. And now you can play around with the new input values to see the layer mask, which we need for the next step. In this part we want to use the layer mask, manipulate to the UV coordinates, so the color information of the textures will be rendered on a different position as they should. Again, we use new variables for this fake distortion. Underscore range speed x and underscore range speed y we are using for the horizontal and the vertical speed of the floating rain. Underscore distortion power define how strong the UV gets manipulated. Because we will work on the UV coordinates, we need more freedom for errors, so we use the pragma line hash pragma GLSL, which has fewer restrictions. Also, don't forget the declaration for the rain speed and the distortion power. Let's go into the rain surface function and calculate first the fake distortion, where we just adding more or less distance on the original UV coordinates. Because the UV coordinates are matrix informations with two values, we work with the data type half2. We calculate the general rain speed with the function half2, which works like the half4 function from the lightning function. We take two half variables and marry them together into one half2. We calculate from the top texture and the side texture two different distortion patterns. For the top, I calculate half2 distortion 1 by multiply the rain speed with the sinus function over of the doubled time. Underscore time is a floating built-in variable which starts with 0 and keep growing just over the time, and because the sinus function flows nice between -1 and 1, it looks like a wave movement. For the side, I calculate half2 distortion 2 but it just multiplies the underscore time with the general rain speed, so the rain just floats down. I know it's not the best functions to fake the distortion, but for the purpose of the tutorial it's good enough. I tried some different functions, and in the short amount of time, neither of them I liked. Here I just replace the test slurp with the raindrops offset and the rain side offset, and add just the distortion offset to the UV coordinates of the rain surface. I also remain the specular lerp to main offset, and don't forget to rename the test lerp in the lerp function. Now we can add the main offset to all UV coordinates and save the shader. And I have arrows. Okay, I forget, of course I don't have any specular lerp now. Just delete this. This looks pretty shitty. Don't forget to don't forget to exchange the texture from the checker texture and to the real texture. Okay, I'm back. I just forget to multiply the result of the lerp function with underscore distortion power and also save the shader. This looks way better, but if you look closely enough, there are still some problems with the normal. We want to change this also. The distortion hasn't not really impact on the specular because it doesn't look like a wet surface. Let's change this and add the specular of the rain texture to our base specular. First we need to change the half to the half 4 data type, because there might be problems working with different data types if we calculate them. We define the half 4 spec at 1 and half 4 spec at 2 and read out the first and the second channel of the rain texture. We want that these textures should move with the same rain distortion, so we define the UV of the rain texture with the distortion 1, respectively distortion 2 for the side. Let's bring the base specular with the additional specular together with negative multiplication. Mathematically, we just calculate A inverted multiplied by B inverted, and the product is also inverted. It's the same method. Like the layer effect screen from Photoshop. We only increase the positive values with the same amount of different textures. Let's write this in the output of the specular color, while A is the base specular and B is the additional specular where we lerp between the two spec add values with the same transition value like above. Of course, we want again apply our editor specular color, so first we use brackets and multiply this content with the underscore specular color. Save the file and check out the result and play around with the specular color to see the difference. The specular works fine, but the surface don't look wet or reflect any water. For this problem we use the reflection of an environment map texture or a cube map texture. What is a cube map texture? Basically a sphere filled from inside with 6 2D 2D textures which simulates the environment with infinite distance around an object. This cube map is frequently used to simulate the reflection of environment on a surface. First again, we need two new properties, the cube map himself, underscore cube map, with the data type cube, and underscore cube map power to tweak the intensity of the cube map. Again, we need the declaration, the data type in CG for the cube underscore cube map is sampler cube. For the cube map, we need another variable in the input struct, video. Like the UV coordinates for a 2D texture, we need a vector which works as a pointer to show us the right point on the cube map. So we calculate this vector half-3 reflected video by using the function reflect with the negative video vector and the surface normal vector. Reflect returns the reflected vector from the incident ray video based on the surface normal vector. The normal vector should be normalized, but to be on the safe side, but I didn't this here. The reflected vectors length is equals to the length the video. Because the video was negative, we get the color information of the cube map where the light ray comes from. So we define the half-3 cube map with the function text cube using our pointer vector reflected video on the cube map underscore cube map with the power function again, and the underscore cube map power. We have a slider mode to tweak. Finally, we send the cube map to the emissive output. Don't forget to save the shader. Either you can take the cube map from the download package, or we just must create a new cube map from 6 2D textures, which should describe all 6 sides of a cube. Let's take the example textures from the overcast 2 in the skybox directory. With right click, create cube map, we create an empty cube map, give the cube map a name, and put all textures in the right slots. If it necessary, change the face side of the to the right resolution of the textures. And now we can just drag and drop our cube map texture into the new slot of our shader and tweak around. You will see this surface looks wet and glossy now. To complete the FakeRain shader, we want to add a rim light based on the floating rain on the edge of the object. A rim light can define the shape and the edge of an object if the light hits the surface slant and with a very little angle. We need again two new properties. With underscore rim power, we set the intensity of the rim light. With underscore rim color, we define the color of the rim light. Don't forget the decoration for these two variables. We jump into our range surface function and define the rim light through our helper function half dot with the video vector and the surface normal vector. Be sure to use the normalize function on the video vector. Make sure that the result is between 0 and 1 with the saturate function. Because we have now just a smooth point in the middle of the object, we need to invert this output with 1 minus the result of the saturate function. Now we have a nice outline. We want to add this outline to the emission, therefore we define half3 add emission equals power function with rim and underscore rim power, this multiplied by the rim color. At this point we have adjustable and colored outline, but we want that the outline should be depending on the rain texture and fakes the reflection on the edge of our object. For this purpose we just copy the lerp from the specular color output and multiply this lerp with the remain of the code line from the add emission. To add the outline emission to the emission output, we use again the same method like from the specular color. Choose 1 minus in brackets 1 minus a multiply by in brackets 1 minus b. Replace a by the cube map and b by the add emission. Save the shader and we are done. Okay, don't forget the semicolon like me again. And now we are actually done with the FakeRain shader. You can try to adjust the settings and play around with the input values. This was actually FakeRain shader tutorial. I hope you like it. And if you want to, you can replace the rain texture with the texture you like more or fit better in your environment. Also, you can try to program a matrix that rotates the rain texture with the object, so it looks like the rain flows always down. In the next part, I show you some features to improve the mood of the scene with the specular, with the particle system, looping sound, the skybox, and the fog. So I see you there.